Good morning to all of you. Myself, Professor N.V. Adpe, working as a assistant professor in Electrical Engineering Department of S&D College of Engineering and Research Center here. So today we will start the new series of lecture that is new course numerical methods and computer programs. In that first unit is numerical computations, errors and concept of root of equation. In numerical computations, we are studied the number of techniques for to find the numericals, to find the numerical techniques. The basics of first one is the basic of new principle of numerical computation. In earlier days, we would use the method to solve the problems. That is, in earlier days, we use to solve the problem by using two methods. That is, first one is analytical method and second one is your graphical method. The analytical method, which is used for the linear problems, but these methods are of limited practical value as most of the problems are non-linear and are of complex processes. Means this analytical method, which is only used for the linear problems, for the linear problems only, but due to the availability of nonlinear and complex processes, these methods are not used to solve these problems, that is nonlinear and complex processes. That's why we use the second method, that is your graphical method. Graphical method. It can be used for complex problems, but the results are not that precise. Means the result of the graphical methods are not the precise, that is not the accurate. So use of calculators and slide rules help to solve the problems manually. Yet these techniques are slow and tedious. Means due to the use of calculators and slide rules, that is other rules, to solve the problem by manually, therefore this process, it will be very slow. It will be very slow. Therefore, with the availability of computers, people people came with new techniques to solve the problems more efficiently and quickly. These techniques are nothing but the numerical method. Means as per the availability of computers, laptop and all other systems, the pupil will be used that is new techniques for solving the problems more efficiently and quickly. Means the accurate result should be get, and also solve the problems quickly. Means to solve the problems fast. These techniques are called as numerical method. This is called as numerical method. The numerical methods are the best tools for solving the problem. For solving the problems, these are capable for solving the problem which otherwise cannot be solved using analytical method. Means by using numerical techniques or numerical method, we can solve the problem which will be not solved by using analytical and graphical methods. The numerical methods are based on stepwise approach for problem solving. For problem solving, these are these factors makes us to learn computer. This is your introduction of methods, that is analytical method, graphical method, and numerical method. The next topic is floating point algebra with normalized floating point form and technique. Here, the floating point form is m b raised to e. That is, in that m is the mantissa, p is the base of the number system, that is binary, hexadecimal, or decimal, and e is the exponent. E is the exponent. Suppose we write the number, one number, suppose 2.5 into 10 raised to 3. Means the 2.5 is mantissa, 10 is base, and 3 is your exponent. That is your floating point number. This is your floating point number. If any floating point number is written so that there is no digit, there is no any digit to the left of the decimal point, to the left of the decimal point, then the number is said to be in its normalized floating point form. Suppose we take a one number, suppose 2.5 into 10 raised to 3. This is your floating point number. But the left side of the decimal point, there is a number present, that is 2.5. Therefore, it is a not normalized floating point. For converting this number into the normalized floating point form, then we convert it into 0.25 into 10 raised to 4. Then there is no any digit. There is no any digit to the left of the decimal point. Then and then you can say that if the number is normalized floating point form. Again, normalized floating point form. Next topic is significant digits. If a number is expressed in its normalized floating point form, then the number to the right of the decimal, if a number is expressed in its normalized floating point form, then the numbers to the right of the decimal are referred to as the number of significant digits. Number of significant. Suppose, for example, the number is 1 by 2. 1 by 2 means it can be written as 0.5. And the 0.5 is the normalized floating point form. Normalized floating point form. Then the number of digits after the decimal point is, in that is 1. Therefore, they have one significant. In second example, the number 1 by 3. It can be written as 0.333 and 3 into 10 raised to 6. Then this is a fraction up to the fourth significant digit. When there is, suppose we consider in that number, we only consider the 3 decimal places. That's why we can say that the number which is up to the 3 significant digits. Means the 3 significant digit after the decimal point. The number 126.4 into 10 raised to 2. Then in that we first normalize it. First normalize it, and after that find the number of significant digits. In that, and after the normalized form, that is 0.1624 into 10 raised to 5, having 4 significant digits. Having 1, 2, 3, 4. 4 significant digits. So in the next lecture, we will see the algebra of normalized floating point numbers, and again after the next topic. So stop here.